Hello, hello. So we are back. We are back this time with some voice commentary because I really want this to be like a useful stream for people to watch again and to check this really complex part of the workflow because tonight I'm going to start working on the small coverts for the wings, and these are the feathers that can be more time consuming to lay down correctly on the mesh, and we are going for a really procedural workflow as always, that is going to give us like a really good result really quickly, but then we will be able to fine tweak everything and everything will go downstream, even when the bird is complete with feathers, with barbs and everything. So yeah, let's start. And I hope that everything is good with volume and also with like the background. I can put like some background music, but really low because I don't want Twitch to cancel the audio of my stream afterwards. So yeah, should be really, really low. Okay, and let's start. So we have our fly feathers, the primaries and the secondaries, and we created the big coverts. Probably still the model. This is like the first iteration of this model, so maybe now that I will start putting all the feathers on the wings, maybe I will find out that I want to change something. But the workflow is really flexible, so we are not scared of changing. Let's go to feathers geos and let's do our usual stuff. We clone one of ours containers. We copy these, and this is going to be the group for the groom for the small coverts. As you can see, just to not get confused, I used to arrange my containers in my scene in a way that resembles a bit the look of the feathers on the wings. So it's easy to find everything. The primaries are here on the outer side, secondaries, and then the coverts above, and the small coverts even higher. So this makes sense. This is something you can adopt as well if you want to arrange your node graph nicely. But of course, feel free to do whatever you want on this under this aspect. It's not really important. So let's rename everything. Wing left, and sorry, I have to move a bit the microphone, otherwise I cannot write. So wing L small coverts, and let's start renaming everything. I might even create like a small script to create a preset for the container, but yeah, for now we are going to rename everything. Actually, the music is distracting for me, so I'm going to turn this off. So small coverts, and we are still using a constant normal. This is something I mentioned in the previous streams. The first thing to do, let's hide all the objects. The first thing to do with the skin before starting using the feather guides is to decide if you want to add to the mesh the usual normal vector or a custom one, fixed one. In this case, for the wings, it's really handy to have this normal vector like this, because this will be the reference direction for guides, and it will be way easier to keep our guides oriented the way we need if we do this. So for the moment, we don't look at the guides and everything because we need to focus on the placement of the small coverts, which is the most important part. So let's rename also the subnetwork small coverts, and let's dive inside. So what we did for the secondaries, the primaries, we simply created a stroke and then resampling, and this way we created the final position points for the roots of the feathers. And this is good if we are dealing with a row of feathers, but coverts are not a row. So we are going to use another node that is going to create a really natural distribution of feathers on your mesh, and then these feathers will also respond to the guides. Of course, if you think that you can get away with these, you can also just paint your density map on your wing and try to scatter randomly feather. But this is something I advise against for several reasons. First, because the distribution won't be really resemblant what we can see on birds, and also because if we go for the workflow I will show you now, everything will be easier also for solving the intersections, because feathers will be generated with already an order. So the first step is to, let's rename this, is to create a knobs surface on the section of the wing where we want to scatter feathers. So let's create some, so let's get rid of everything except the stroke, clear, and let's create something like, let me zoom in. Okay, should be okay. And let's create something like this. Okay, it's not really visible, so I will turn on the point. So like this, 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 and this. So now we have these strokes. And we create a guide room node. First, we resample. I cannot really see now the strokes, and I wonder why. Okay, no, yeah, they are. But I'm seeing the mesh. I don't want to see the mesh. I don't know. Oh, okay, hide. Why am I seeing the mesh? Let me see if my viewport is working correctly. This is weird and a bit confusing at the moment. This shouldn't be visible. Oh, okay. It was still selected somehow. Sometimes my viewport in Houdini is acting weird. Okay, so we have our curves here. We resample these curves using the segment options in a way that they are all of the same number of points regardless of the length. And then we plug this into a guide room because this will allow us to do some retouch. And we switch to the old guide room, which is way better for us. And then what we do here is just on the fly, we create a sort, and we sort the primitives, so the curves, from left to right, so by the x-axis, and we create a skin node, which will work as a loft. So we have something like this. It will be better to add more subdivisions, so now when we are going to subdivide, it will be better to add more curves to create this surface. So now that we subdivide, we don't get something with such an uneven density between like the two directions. But yeah, we can do this later, and it is not really crucial. But yeah, let's subdivide a couple of times, and then let's look also at the mesh in transparency. So now we created this one. We are going to use this one as an NURBS surface. So we convert this into a NURBS surface like this. And then we can use this Godfeather node, Godfeather scatter by rows. This is a node with several options. I'm going to show you before paying attention to what we really need for the bird. I'm going to show you the basic behavior of this node. So how does this work? You simply connect your NURBS curve, and then also you can connect the skin of the bird from here, basically. And we will use this first surface to scatter the roots, and the second surface just to snap the roots to the right position. So how this work? We simply have two ramps for tweaking the density, but now of course it's quite confusing, and I will reset these ramps to a constant value here and here. So also now I realize that I want to invert one of the parameters of the surface. So before plugging these, I will reverse the let me see if I'm reversing the right one. I have to reverse V, because when I tweak this density, not this one, but this density, I want the upper row to stay still. So this is the way it should be. And probably for the side, for the horizontal one, you want the inner part of the wing to be the one that is fixed. So like this is okay. So as you can imagine now, probably you already know where this is going to end. We are able to create rows of points that will create the typical pattern of coverts on a wing. So we want the density to be something like, yeah, let's go higher, to be something like this, for example. And also, on the upper part of the coverts, we want more coverts. So something like this. Of course, we will need to tweak this several times the moment we have our real guides in place and we will see the actual shapes we are creating. But yeah, this is just to introduce you to the behavior of this node. Also, we forgot something here. When we convert to an NURBS surface, the order of the interpolation of the surface needs to be 2. Otherwise, you're going to get some weird distribution. So this is our like basic arrangement for now. And of course, you can see that the points are not following the surface because the points are following the model. We also have other options here in this node, because if you need to fine tweak the distribution, you have a gamma for the vertical direction and the horizontal direction. Also, you can create some randomness, but in this case, we don't want too much randomness. You can change the seed of the randomness, and you can use this offset if you want to find a really good way to offset every other row to make it like pleasing to your eye. Also, sometimes you don't want to use like the whole surface to distribute your points, so you can always change the boundaries here. If you don't want to use this part of the mesh, you can simply push the boundary using this ramp, and you can create, this is a constant shape, let's create something like this. You can create any shape here. So if you want to push your points towards the outer side of the wing, or you want to keep some parts of this clean, you can use the boundary and fine tweak the behavior of the node. And also, if you have an attribute painted on your skin, you can prune out some of these points. I will show you here. Let's create an attribute paint for the body. And let's call the attribute prune. Let's say that I don't want stuff here and here. Now if I go to my points, I remove that part. So you have several ways to affect the distribution of the points created by this node. You can push the boundaries if you want to simply relocate the points you already have. But if you want to get rid of some points, you simply paint the attribute on the skin of the body, not on the knob surface. In this case, we are keeping everything, so yeah, let's bypass this. It might be useful later, so I'm leaving this here. Also, these points are coming with some useful attributes like p-scale. If you look at p-scale, p-scale is being assigned, where is it? I don't see p-scale because I didn't select the node. Yeah, p-scale. We have p-scale, and this attribute is going to reflect that some feathers are supposed to be tiny and some other are supposed to be larger, and you will be able to use this attribute in your feather generation. So if you want, you can get automatically your correct size for your coverts even without relying that much on your feather guides. Or you can use your feather guides, or you can try to find a combination of the two, whatever it fits more your workflow. So now we had this one, and this is going to be the first output of this network. And so now if we jump on the feather generator, this is what we have here, but of course, not all the feathers are being scattered because the guides are not in the right spot. So now we will add some standard guides to the region where the coverts are supposed to be. So let's turn off the wing preview, and let's go to feather geos and the guides. We get rid of everything. We create another one here. We get rid of the last one. Also, we lift this one. We need to increase the ray bias here, because otherwise we cannot pull this out of the skin. And we create a really tiny shape. Something like this. And also probably what we want to do is that we want them to be generally wider. So maybe something like this. And also slightly different shape. Well, in the case of our bird, actually no, because our bird has completely different shapes for the coverts. They are quite pointy. These are the coverts of this bird. Of course, it's not really clear from here because there is also the color pattern, but yeah, let's try to find a good resolution. Yeah, these are the shapes for these heron. So yeah, let's create something pointy. Yeah, for now, let's keep these for now. Apply. And let's start placing other guides just to have a good coverage of the area we want to groom. So like this, 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 and this. Now, they are lacking some attribute now. Let me check what they have wrong. Okay. That's weird. I will recreate the guides because before it was perfect. Maybe something with the creation of the new guide. So we are still finding some bugs, as you can see. So let's reset this node. Now it's clean. And I'm going to create a new guide from scratch. Oh, I know what it was. Let's go back because this is really instructional. So our problem with the guides were that as I kept a random guide from before, and I had these checkboxes here, shape, profile, twist and curl, attributes, and the profile was turned off. That means that none of these guides is affecting the profile. And of course, this is a mistake. So we turn on the profile as well. And so now here we have our feathers correctly. So let's increase the radius because still we didn't find everything. But before doing this, it's better to jump to our object level node. This one, this is the node we use to check the placement of our feather roots, and we will add our new roots here. And also, let me check here that everything is okay. Okay, these are points, unconnected points. And now we go back here. We are not seeing anymore the other ones because these points are coming with a p-scale. The other points didn't have a p-scale, so now we are using the p-scale attribute, which is not being initialized, and it will be 0 for some of them. So what we are going to do here is simply to get rid of the p-scale on points. So we get rid of p-scale, and we have our spheres back. Okay, so now we are seeing seeing a better view of the arrangement, and we can keep this, of course, and we will be back on our network, and we will fine tweak the distribution of the coverts here. So let's go to the scatter by rows. And we need to tweak this. I use the B-spline interpolation usually. And yeah, let's start creating a nice profile. Okay, so for this one is kind of okay. Okay, yeah, I will keep this for now. I'm not sure I like this final gap. No, I don't like this, so I will push this even more, because I want this space to be larger and larger, and probably I will tweak the gamma as well, like this. Yeah, let's keep this for now, and probably we have way too many feathers on the upper row, so I will increase a bit. Not this one, but this one. Yeah, this makes more sense. Now we can be back at the feather generator, and let's increase the radius. Now we are sure that we are spawning feathers everywhere. Okay. And the first thing I will show you is how to get automatically some adjustment for the sides. So let's hide the roots here. And let's go back to feather geos. These are our feathers at the moment. So the way we can affect the sides, taking into account the p-scale that is coming from the roots, is this one. We need, so let's check that everything is nicely renamed. Let's create something like this. Small coverts, left side, roots. We jump into the internal subnetwork, the one that allows us to do further processing of the curves. And what we will do now is that we can create first an object merge. We import the root. So these are the roots here. And now with a wrangle, we can connect this and this way. And here we are going to do something like copy p-scale to primitives. And now what we need to do is we create a new attribute, feather scale, and this will be on the primitives. And we will read this attribute from the points coming from the second input. So we will do this, like this. And here we want to use print number because every primitive will be corresponding to a single point on the second input. So we will use the primitive number as the point number in the function point. So point is going to retrieve the p-scale attribute for us. So now if we look at our feather primitives, which are not yet feather primitives, they are curves at the moment, they have on the primitives feather scale, and this is coming from the points. Now that we have this, we can use a guide process. Actually, I don't want this connection. Yeah, we can use the guide process this way. We don't need to connect the skin for this operation. And we are going to use the set length with the multiply. The scale is okay. And in scale factor, we are going to use guide attribute, feather scale. And now feathers are automatically scaled according to the primitive attribute. Of course, now they become really, really tiny because the values of p-scale were really, really tiny. But yeah, we go with a factor by 10, and we have this automatic scaling of the coverts. Of course, when you are working on a character, this won't be enough to be accurate because we don't know if this transition, this progression of sizes is okay. So my advice is, of course, you can compensate this with the guides because this will still be responding to the guides, and now we will see that. But also, if you want, you can change the way you use the p-scale. So in theory here you can do something like this. You can reassign a value to feather scale, and what I usually do is that I simply do like a gamma transformation of the value, something like this. And maybe a final multiply to get again a sensible range of values. So gamma 1 multiply 1. So this is our distribution back like before. But if I change the gamma, I'm making the difference more extreme. If I go to higher values, let's say that I go with 2, of course, I'm getting a difference which is quadratic compared to what I had before, but now I have to compensate the numbers, so I have to multiply again. So this way, compared to before, we are getting a more extreme difference in sizes, and you can adjust your values like this. If we go back to the feather geos now, we can see that we have our differences in sizes. Of course, now these are way too tiny, so yeah, let's go back here, and I think that something like 1.3 was okay, and now these are too large, of course, and let's reduce these. If you want a better visual feedback, of course, you can pin the viewport and you can work here, or you can pin the parameter interface and you can work here. So let's see if we like this. Yeah, it's quite good for that one, but those ones are really too large. Maybe we don't even need this additional row of coverts. Yeah, it's something that we have to check again. Or we can affect the size of this with the guides again. So I can go here to the Godfeather groom. And now I will also rename this stuff. Small coverts for the primitives. And let's go here. Let's copy this one. And let's change this. Of course, this is failing now because we are using an outdated deform. This is something that we still didn't do, so let's skip the deform. We were, just to explain, we were using the deform node with proxies that belonged to the secondary coverts, so that's why it wasn't working. We still have to go through that part. So definitely the last row of coverts is too large. We don't want that extreme change. We can adjust this in several ways because as you see from like how this network is built, we can use anything here. We can mix this with any attribute. We can use an attribute that is coming from the skin. We can paint something to tweak the scale of the feathers, or maybe just more handy, we can tweak the scale of the feather using the guides. So let's go back here. And if we want to affect this, we will place it. So now what we are going to do here is that we still want to use that mode that I showed you last time, the composite guides. And so let's say that we want to keep just one feather guide to affect the profile. So we will keep maybe this one. So all the other ones, we are going to turn off the profile influence. Okay, so now we can create another row of guides to affect this really last row of small coverts. So let's create something here, here, here. All these should be done continuously, looking at the reference all the time, being really careful about everything. Of course, this is grooming and it requires patience. The tool is really powerful, but it's not going to replace your artistic mindset and your care, basically. So now let's select these new guides we created, these, and these. And we can use the adjust length to reduce them to a smaller size. So 0.05 is still too much. Let's go to 0.01. Okay, this is probably too much as well. Yeah, let's do like this. I don't want to see the other mesh for now. Let's do this one. And let's look again if we got what we need. So our only problem here is that, okay, all of them are scattering, is that we have to tweak the influence. So if we increase the decay, we are getting something like this. We are increasing the decay. That means that guides are way more influent. They are affecting more locally. So this last row of coverts is responding more to the small guides we placed, and that's why they are getting smaller. So let's increase the decay a lot. Okay, we have something like this, and now we see that probably our density is not really okay because they are not enough. If we want to change this, we can even pin the viewport here, unless we realize that everything becomes too slow. And let's increase a bit the density. Okay, we are increasing. Yeah, this is a side effect. This is something that we might want to change. Because of course now when we increase the density, we are also reducing the size because we bound the P scale to the sides of the feather. But yeah, let's do this anyway because we need more density. Let me check before without this. Let's double check like this if we are doing correctly. Okay, sometimes it's confusing. Okay, yeah, no, this is not what we want to do. This is not. Okay, yeah, we want to increase this, both of them. So we are getting more feathers. These are more feathers. And now we simply have to go inside these again, and we want to change the multiplier. Maybe even more. Okay, that's fine. For now, this is our arrangement. Of course, we need to fine tweak a bit the guides because we don't like this. Even if we are going to wrap these geometries to surface, we still want the guides to follow like the final shape at least a bit, because otherwise the wrap will look too weird. So we are going to create more guides if we need more guides, or we are going to change the ones we have. Let's find a good arrangement. So I think that I will keep this like this. And then, yeah, I will select this like this. Screen brush. I will select all the guides just to be really quick. Let's see how responsive is the viewport. It is still okay, I would say. But if you want the viewport to be more responsive, you can use the trick that I showed you the other day. So feather generator 5 is the feather generator to connect to this Godfeather groom node. We connect this, we go here, we click update on demand, we update once, and now we have the guides that are really responsive, and the update of the feather generator is going to be delayed. But anyway, I think that I will prefer for now just to create nicer guides just following the shape of the body. So let's be careful to the shape of the body, and we can adjust all our guides. We sometimes need to select a single one to, oh, I forgot to, let me go back because I forgot to turn on constraint length, so I need to go back a lot. Okay, so constraint length. Okay. I don't want to spend too much time on this now. This would require a lot of care. I want to jump to the other thing you would like to see, I guess, which is wrapping these feathers to a surface, which is something I actually did today on another character. Let's just try to get something barely decent. Okay, yeah, let's keep this for now. And now what we have to do, we need to go back to this subnetwork, the one where we created the surface to scatter the roots. And we will try to create the wrap surface. To create the wrap surface correctly, we need to adjust to prepare our preview. So we don't need for now these feathers, we just need to see these ones. We jump to the subnetwork. We will grab these curves. We will create another guide room. We reset. And also still we copy sort, skin, subdivide, all this stuff. And what we will do now is that we will jump on this guide room and we will adjust the curves we use to generate the surface to follow the shape, the outer shape of the feathers. So we will create a volume, something like this. And we are going to extend this curve till here, where we plan to cover the big coverts. So let's do this really quickly for all of them. We can also resample. All this stuff is really procedural. You can jump anytime to any of the surfaces you created for scattering the roots, and now for creating this wrap surface. And later I will show you that you can always tweak the surfaces, run the solver again, and you will get a new arrangement for your feathers. So let's put this a bit lower. When you start working like this on live with people watching you, you realize that actually things require some time to be done. And I would like to show you like as much as I could in a single live stream, but yeah, the alternative is that I have to rush everything and maybe the explanation won't be that great. So let's try to get to a slower pace, because I want to show you how effective actually is this workflow, and not messy at all. Let's get like a basic wrap at the moment, and we will tweak this later. Let's also adjust this shape. Okay, let's pretend that we are okay with this one. Something you can do also is that before using these curves to skin, you can put a resample. You turn off everything because we want just to create a curve U. And now this mesh has a curve U attribute that is running from here to here, and you can use this curve U attribute to, well, let's do this, I will show you. Let's say that even if you want this skin to be really, really smooth, so coming from something like this and then subdivided, you don't like here, of course, that is not following properly the shape of the body, of the wing. So if you want to snap back something, especially in this region, you can do array. We grab the body. Actually, after the subdivide, like this. We use minimum distance for this one. And also, of course, we don't want this mess. We just wanted to get a fix here. So what you can do is, I hope that this doesn't become too technical, but you know, it's just building geometries that we need for working, and every Houdini artist, especially if it's like a generalist, has his own strategies. What I usually do is something like this. I simply create a blend shape, and I'm reading the blend like this. And then I'm using the blend to create something like this. So I'm mixing the positions from the original shape and the shape coming from the ray node. Now I will connect the ray node to the second input of the wrangle. So something like this, close, and then I connect this to here. And if everything is correct, So this is the original one. This is the one where we snapped some points here. And what we want to do is simply to let me check that. Oh, I wrote spine U. This is an attribute that I use on feathers. It's curve U, of course. Here we are. We are snapping only the things we need. Let me check again that I'm doing this correctly. So where spine U is low, we want to wrap, and then like this. Yeah, something like this. We can use something like this, even if it's not really perfect. I don't know if I want to keep this for this shape. Well, for now, let's keep this one, but of course, I will show you later how to clean up the shape at the edge. But yeah, what we will do now is that this will be our wrap surface. Let's create another output. So this is output 1. Let's get rid of these because it is confusing at the moment. Let's create another null for this output. So this is the wrap surface. And what we can do now is grabbing our proxy. These are our proxies. And we can use a Godfeather primitives wrap. I hope that the wrap surface is going to be enough. It should be a bit wider, definitely. And also feathers here should be shorter. So let's try to cut. Okay, yeah, let's do something like this. And then we plug these proxies to the wrap. And they are going to be wrapped to the surface. Let's do a complete wrap using the ramp like this. So now they are completely wrapped. Let's check if the surface is subdivided enough. We can subdivide this even more. We can exaggerate. So this is the wrap. Of course, we are getting these, a lot of intersection, but this is completely normal because we are going to use a lift here. and we can lift slightly our feathers, or even a bit more, yeah, something like this. Now the final ingredient is the solver. Godfeather solver. We put the license manager here. Let me save this scene. Sometimes I'm really confident that nothing is going to crash, but I have to admit that maybe once per day, or well, if I'm lucky, there are some days without any crash, but yeah, this can still happen. But yeah, no crashes in live so far. And yeah, let's connect the curves here. And now we have a really important aspect for the feather solver, which is that all these feathers have been generated with an order. They are ordered by row. Here the shape is not nice because we don't have the wrapping surface going there. You see the wrapping surface is ending here. Of course, we need to prepare really carefully the wrapping surfaces and the guides, and we have to pick our strategy to drive the sides of the feathers. Of course, as always with Groom, the most straightforward strategy is to use guides, a lot of guides. I wanted to be really lazy and to be helped by the P scale, and I created this automatic scale here. But maybe it's something that is going to save you time on the when you're starting, but after that, when you want to fine tweak, maybe you regret this and you prefer to work only with your guides. If it's up to you. If you want to work only with your guides because you feel you have more control, you don't use anything like this. So let's go back to the solver and let's check by index, because we are going to solve everything by index. Let's try some really basic settings, because first we want to check that the order is correct. So yeah, iteration 1, and let's put this here. I will go through like all the settings of the Godfeather solver. Maybe I will create a tutorial, something I will record, not on live. Okay, yeah, like this, the blur. Let's go. And now it's done. Let's see what it did. Okay, it's something. Okay, it's the opposite, so reverse index, solve. Okay, it was the opposite. This is okay. We need to completely change the scale here because lift 0.1 is too much. So let's go for something smaller. And then we will increase the iterations because this is too much. Okay, we are getting almost there. Now I will increase the iteration to 4. And let's go with another run. It's taking some time. Okay, that's it. This is what you do when you want to create the coverts. Of course, these are ugly looking because the distribution is not really correct and the wrap surface is not correct. But what I want to show you is how fast you can achieve something. And now everything is really, really procedural. So if we realize that these are too many, for example, these are way too many, we go back here to the scatter by rows. We realize that we created too many coverts. These are too many coverts. We go here and we reduce these a lot. We reduce these a lot. Now we have to check again, of course, our scale. They are too big. This is the reason for not using probably this method. This method is not really smart in this case. Let's go back here. Let's compare to the this is too much. Okay, too much difference in density, horizontal density. So let's go back to scatter by row. We want more feathers here, like this. Okay, and let's go back here and let's increase this to like 15. And okay, I did this tweak. It's not perfect yet. As you can see, it's not perfect at all. I can make feathers a bit wider, maybe. But anyway, I have, of course, to tweak the amount of feathers, but just to show you how everything is procedural. Then we go through the wrap again, the lift scale again, and the solver again. I solve again. And here I have my update, so I can iterate towards the correct result. Also, these don't look really nice because they are not random at all. I want to remind you that here in the feather generator, you can always create another set length. And you can use it for randomize. So multiply, scale, randomize, and you can put something like this, or even more extreme, maybe from 0.9 to like this. And also I created a new node to achieve the roll. The roll is a rotation. Oh, Franchino, ciao Franchino. And yeah, the roll is this kind of rotation, this, and you can randomize this as well. So with a minimum and maximum roll, you have the seed here if you want. And we are getting something a bit more random now. We can exaggerate everything. If we want to get a really random look, let's go like this and like this. So this is our new input. They are more messy. And we will need to run the solver again. But before running the solver again, for example, we see that we don't like the surface here is not tight enough, and we can resculpt the surface, the wrapping surface, going here and jumping to this guide groom, and we can push downward these curves. And it's just a matter of iterating a lot. So let's do another iteration with the solver. And let's check. So these are our coverts now. And yeah, definitely we want to change the density and the scale here. Let me check which kind of guides I have in this region. Yeah, for example, I want to make these bigger, definitely. So I will make this bigger like this, not too much. And also like this. Probably a bit bigger here. Yeah, definitely the sides with the guides is the way to go. My advice is to use that one. And maybe we still increase a bit the general density, going here and increasing again the general density. Let's do another solver run, and then I think that I will end the stream for tonight. As you can see, even if the workflow is really flexible and is really procedural, you still need to plan everything really carefully. Tonight I wanted to show you like technically how things are working, and I didn't look at my reference enough, but you should do. You should look at your reference all the time, and you should check if the coverage is okay. I recommend to use these a lot, but actually I think that I'm not sure that all the feathers are spawning. Let's see if they are. Yes, they are. They are simply too short. Okay, but anyway, yeah, this is the workflow for the coverts. We will go on with fine tweaking these small coverts on the next live stream to make them like look nicer, and also we will look closer at all our references. And maybe we can also, something we can do right now, because I want to fix this before the end of the stream. I want to get rid of this strategy for the guides. I don't like it. Okay. And also of this, we don't need this anymore. And we will follow a complete the old approach with the guides. So let me fix this so I leave you with the correct workflow, because to use that one and to use guides for compensation is not nice, because as you can see, every time that we change our mind on the distribution, we are losing a lot of things. So yeah, let's stick to the guides, and let's reset everything with standard sides for all of them. And now, of course, we can use the screen brush or something else, whatever is more convenient for you to get this right. Probably you are going to need more guides compared to the one I used. Let's go really tiny here, but quite larger here. And we want to visualize like this. Actually, on this bird, you can see that on this bird, coverts don't really get that small at all. Let me check the best reference I have. Yeah, they are quite big, and my advice is to create this kind of groom for the small coverts, but for the really small ones on the edge of the wing, you can create another row. It's easier to create another row than just trying to fit everything into like a single groom. To fit everything into a single groom will become really, really complicated, and there's no need in overcomplicating this. One of the biggest challenges in like any Houdini grooming workflow is to get something really useful on your viewport. As you everyone as everyone knows, if it's working with Houdini, you need to arrange your viewports, your object level, your visibilities in a way that it is handy for you, because otherwise you never know what to focus first, and you cannot check if you're doing good. Now, I don't want to complicate the screen in live, but it will be way more useful to do this. You can simply split left and right. Now I'm working on a single screen, but you can simply do these. You go to the object level, you turn off these, you pin this viewport, you go back to your feather gears, and here you hide everything, and you work only with your guides while checking these. Of course, you are checking this without the wrap, without the solver. It's not ideal, maybe. If you want to check this with the wrap, it will be slower, but you can add another wrap at some point. But yeah, let's say that we decided that this is the setup we are going for. Let's close this tab and let's make some space again. So we go back to the solver. This is the old group of feathers solved. This is the new one. And let's hit solve again. Okay, we have our solving. And as always, this solver worked for the proxies, and the proxies are going to deform the main feather. So we use a Godfeather deform, we put it here, and we connect the original proxies coming from the fourth input of the feather generator and the solved proxies, and this is going to copy the deformation of the proxies on the actual feathers, and we just need to adjust the capture radius. We go to 0.5, for example, and this is the capture from coming from this is the deformation coming from the proxies copied over the main feathers. You need to find the good value for the capture radius, the one that is giving you like the nicest result. Of course, if you go too small, you get this, because not all the vertices are going to be captured by the deformation. If you go too high like this, it's nice looking, but the deformation could be too smooth, and not follow all the subtleties coming from the proxies. So it's up to you to find like a good spot. This is quite good. As an arrangement, it's almost intersecting here, but yeah, when zooming in is quite okay. And yeah, that's it. This is what the way you want to work with your coverts. They start to look a bit more bird-like, but yeah, definitely you want to work with some more care. Also, the big coverts are not really similar to the reference at the moment, because we are arranging all our feather groups in our Houdini scene, but still we didn't really start with the artistic process of the work. But yeah, this is it. Again, for this boundary, for this edge, I suggest to create another single row of feathers. So with the same workflow we used for the fly feathers, single row. We don't need to do something that complicated with the surface. I just want to recap, to summarize again, the workflow for the coverts. So we create the usual subnetwork to create the roots. And what we did here, let's go again. We started from the body. We created some strokes over the body, resample, guide groom for tweaking these shapes in the case we need it. We sort these primitives by x-axis from left to right, right to left. This is just to be sure that the loft is going to work correctly. And once when we subdivide this surface, then we convert that in a nub. The nub surface needs to have these order to 2, which is the minimum. We reverse some parameters if we realize afterwards that the U or the V needs to be reversed. And then we use the scatter by rows. I spoke a lot, way too much about this node, but yeah, this is a node that is basically using the UV of the parameter of a nub surface to allows you to scatter points using all these settings. Probably you notice that we have too many points here. You don't want this vertical concentration of points in these sections. If you don't want, the solution is always the same. You don't have to compress the surface that much. You can jump back to your curves here, these ones. You can extend this curve a bit. And then you are going to create some points that are going to fall outside of the shape of the body, and you can get rid of them just painting the prune attribute, or getting rid of them manually is fine too, or you can get rid of them with like a region created with like a standard Houdini node. So after you create these roots using the scatter by rows, you also need a similar surface as a wrapping surface. So you start from the same curves, you go to the guide groom. Also remember that if you need to be more accurate with your wrapping surface, you can always use the guide groom to add a new curve, which is something that I suggest you. Definitely you can go here and add a new curve. Let me select this correctly. Why is it not doing this? Oh, I didn't connect the skin. So you connect the skin to the guide groom, and now you can add a new curve here, and your surface is going to be more accurate. Of course, you need to tweak the new curve with the brush. I don't know why the new curve is so ugly looking, but yeah. Let's increase the ray bias so we are sure we are capturing these. And with this, basically, you can be more accurate when creating your wrapping surface, but this is something that you will do slowly. At the end, after you create a wing, first you can mirror this wing to the other side. But basically, the wing is the most complex task probably in doing like a feather groom. So take your time to shape correctly your wrapping surfaces. You see that this is really raw, but take your time instead and use as many curves as you need and create a really nice looking wrapping surface for you. This wrapping surface, so yeah, just to finish with the recap, we are going to use the roots in the feather generator, and the feather generator, exactly like we did on the fly feathers, is going to generate feathers at the spots we provided with the roots, following the guides. And after the generation of the feather primitives and the proxy primitives, we will simply use the feather primitives wrap to wrap the primitives to the wrapping surface. This is going to produce something like this, and then we want to create a lift to give this some space. Also, like a super tiny advice I can give you, of course, is that not all the feathers have to be lift of the same amount. You can use a guide attribute. Probably you want to lift the bigger feathers less than the small ones, because the lift is by angle, and of course with a bigger feather the same angle is going to produce a wider gap. So you can paint a map for the lift effect, or you can even use the feather length attribute that is already on the proxies. If you look at the properties of if you look at the attributes here, you have f length, so you can try to compute automatically the lift amount using the f length, binding a higher lift to the smaller feathers. This is something I did, and this is again really procedural, and it's quite easy to find the sweet spot of all the values, and you don't have to paint stuff, and you can go really quickly. And so after the wrap and the lift, you can use the solver. Remember that you need to use the solver sorting the feathers by index, because feathers have already been created with an order, and as you can see, feathers on the upper right are above the neighbors. So we start on the upper right. So the right here is the inside of the wing, and this is like the correct arrangement for a bird. And this is it. You have your proxy solved, and we are going to deform the main feathers that are really subdivided with the feather deform, and we have our coverts. Yeah, they are not the best at the moment, and of course here we are missing the allulas, which are that group of feathers that are connected here and that work a bit like the flap on airplanes. And we need to work really close with much care to the connection between the coverts and the allulas. But in general, of course, the coverts are above the primary coverts and the allulas. This is a really tricky spot. This spot needs to be done nicely. And of course, we are going to tweak a lot our feather guides, because we want to have control on the orientation as well. So if I want here feathers to be rotated more this way. I do this, I do this, and then I jump back. I don't even need to check everything. I jump back to the solver and I run again the solver. So a good advantage of working, yeah, the solver already did his magic, and we have the new arrangement for this spot in the small coverts. Of course, again, you shouldn't abuse the solver. Why? There are several reasons for not abusing the solver, but one of the reasons is, for example, that if you are working nicely with the guides, so not like I did tonight, scattering guides like in 10 seconds, but if you are working with some care on your guides, your small coverts will already look okay without the solver, and this will help you a lot in terms of visual feedback, because you have something decent to look at before the solver. The solver is not real time. The solver, you need to click it every time. So yeah, that is one of the countless reasons for being really careful with your guides and having something decent even before the solver. So yeah, this is the workflow for coverts that are scattered on like a surface. I don't know if I want to work on this a bit offline, or I will simply go on with cleaning this up for the next live. I don't want to work on this offline actually, because I want you to look at the like real workflow, including like the struggles, the problems, and the mistakes. I think that this is more useful for you. So yeah, we will continue on this wing next time, and if you see me that I keep working without looking at the reference, warn me next time. Tell me, Fabio, please look at the reference, because you are not being really careful. And that's it. We next time we will try to complete all this part of the wing. So we miss the allulars, nicer, smaller coverts, the really small coverts that can be placed at the boundary here at the edge of the wing. And then we will try to fine tweak also the shape of these big coverts. Probably here we are missing one feather. These are not enough. The density is not enough. Yeah, that's it. Just as an eye candy, because maybe you are tired of just seeing geometries. Yeah, thanks, Franchino. I need a really strict lead telling me that I have to follow the reference. So if you are sick of watching colored geometries all the time, we can do a small jump towards like the end of the workflow, but I think you already know how that works. You can create a feather system here, and let me save. I can create a group just for convenience. Let's create a group that we call all feathers. This is something I do only now, just to show you something. And let's connect all the outputs to this. Okay, we have all feathers, and we go here, we put the license, we connect all feathers. They are 300. Done. Quite fast. These are the feathers generated with the primitives we created so far. So this is how fast actually you can work, and as always you can jump in Karma and you can import the body and the feather system. You can switch to Karma. You can put a light. It is a bit big. And you can check if you're doing nice. The barbs are really, really big because, of course, we would need different templates for everything, even if you can achieve this even with a single template. This is not really nice, but yeah, I show you how fast you can improve this, because, and then I will really leave you. I quite enjoy working with this creation of mine with this tool. That's why I keep saying that I'm going to terminate the stream, but I'm still here. So you see that you have a big gap here and you don't like it. Okay, of course, the wrapping surface is not accurate. So you simply go here to the feather geos. You change your preview here. You don't want to see the feather system in the viewport. You just want to see this here. So this is not okay. And let's go to the feather system, to the feather geos, this subnetwork. We jump to this guide room, and we know that we have to push down these curves here. Let's push down these. Let's push down these. Just a bit. And then you go back here, and you already know. You simply hit the solver again, because the solver is the only node that downstream is blocking the update, because it needs to be triggered by the button. And as you can see, now they are closer, and we can jump back on the Karma render. We have to wait, because with the new feather geometries, the feather system is recomputing, and yes, we have these, but I push the wrapping surface too much, and I eat a bit the skin. But anyway, this is just to show you how quickly you can go with fixing your wrapping surfaces. If you now spot something wrong here, you simply go back here. Yeah, it was really easy to spot. You simply turn off these, and let's jump here. Yeah, we can see that the wrapping surface wasn't okay, and probably also we want more precision. Let's create another one. We definitely needed another curve here to describe the shape. And again, we can even jump to the USD stage. We pin the viewport. We jump back here, and you know what we need to do. We need to click on the solver. So let's solve these. And now after the solver has finished, all the feathers of the feather system will be regenerated. And we are going to get something a bit nicer. Anyway, these were, yeah, we have something nicer here. These were like almost 2 hours of work. I'm confident that after getting the grip of the tool, you can achieve like a nice wing, maybe in 2 days, 2 days of work, 3 days of work. The other time in 2 hours, we work really slow for the fly feathers and the big coverts. Now we started working on the small coverts. We still need to work on the other side of the wing where we will have the under coverts, of course. But yeah, after becoming good at the using the tool and with a good study of the reference, I think that you can create a nice wing in like 2-3 days, and you have your first pass. And the good point is that everything is procedural and can be improved quite effortlessly. And yeah, this time is really it. And I hope you like that here everything is clean. You don't have big intersections in this part. If we want to look at this better, I will jump in my feather system and I will make the barbs thinner. So I reduce to 0.00003 the average width of the barbs. Of course, this is not the way you work with the feather system, because you will have at least a feather system for the fly feathers if you want to put together the primaries and the secondaries, a feather system for the coverts, and then one for the small coverts with all the variations using the prim bars. But the important thing is that you don't have, thank you Franchino, grazie, and you don't have to split the grooms and also let's increase the spine cut. You don't have to split the grooms and the feather systems the same way. You are free to split the grooms. The way is more convenient to work artistically with your guides and with the tools of the feather generation. And then when it comes to creating the actual feathers with the barbs, then you can start thinking with a different logic. You can simply put together the feathers that you think that are something you can achieve with a single template using variations again. So now I'm regenerating feathers, and yeah, now I have actual feathers here. But of course, this is too soon. I just wanted to show you like the second part of the workflow. This is too soon to generate the barbs. But yeah, this is quite easy. And of course, if we are thinking in terms of production, if this is not the first bird you did, but you already did another bird, probably you will already have a feather system coming from another character. You already did nice primaries, nice secondaries, nice coverts. So you can literally copy and paste the nodes from another scene, from another character. And as long as you are consistent with your primvars and you are using the same names for the primvars, basically everything will work instantly with a different character. So for production, this is quite important, because this means that if you or your studio starts working on birds, in a while you do 2, 3, 4 of them, and then you are going to become super productive, because you just need to do really carefully this first segment of the workflow, the creation of the proxy of the feather primitives, the geometries, and then you already have a really good set of good looking templates coming from other birds, and this is going to save you a lot of time. So yeah, that's it. The next stream probably will be silent, because this was more for explaining, but the next one is for being careful about the workflow, and being careful about the shapes, the distribution of the feathers, and to be more accurate with the wrapping surfaces, and to make this nicer, basically. So I think that the next stream will be just me working on these and spending some time on improving the look. Okay, so we did 1 hour and 52 minutes. I hope you enjoyed this one. I know that it was a bit less straightforward than building just a bunch of primaries or secondaries. But as you can see, we got to a good point quite soon, and now we just have to fine tweak. The powerful thing is that we are not committed to anything that we did. We didn't spend a lot of time. Everything is procedural. We can tweak the surfaces. We can tweak the scatter, and we don't have to regret anything. We are not stuck to anything that we decided. Okay, nice. Thanks for watching. I hope that also more of you are going to create a Twitch account to interact with the chat, because I would like to answer also questions sometimes. I will announce again the next Twitch stream on the Discord group, on the Discord server. And yeah, see you soon. Bye bye.